Hello student, today's topic is non-deterministic finite automata. Okay, so first we see what is determinism or where it come from. Deterministic finite automata, the deterministic words come from determinism. So what is the meaning of determinism? Let's see. So in case in DFA given, this is the diagram of DFA. So in this diagram, what was the current state? This was your current state, and we know that it goes to next state. So in given DFA current state V goes to the next state. Okay, and it is very simple. Second one, it has only one unique state. So what is a unique state? Because this A state goes to the B state. There is no other state it goes. It has to go on to the next state. Okay. So with one input, because with A with one input it goes to the B state, with zero input it goes to the next state. And second one, it has no choice or randomness. Okay, there are the multiple states, but it not go to the multiple state, because A not goes to D not goes to A go to B, or A go to C. Okay. Last one is, it is very simple to design and it's easy to design. So this is the DFA. So next we start NFA, non-deterministic finite automata. So here an example. This is a diagram of NFA. Let's see. Zero, 1. Okay, look here. This is the state A. Okay, so this is the current state, and there is multiple states which it could go either A state or B state. A should be go A, other B, otherwise it goes to D. So this is a deterministic, non-deterministic finite automata. So let's write here NFA, given current state, there could be multiple next states, because A can be go B or C, or it goes to C or D with 0 or with 1 input, because with one input it goes to B, and also it goes to D also. Next we write here, the next state may be chosen and randomly. I already told you, because A can be choose B, C, D, or it can be goes in next state. Okay, it can choose randomly. This is E is epsilon. Okay, what is next statement? Statement is the next state may be chosen at random. Okay, last one. What is the last statement? All the next states may be chosen in parallelly. All the next states may be chosen in parallelly. What is parallel? What is the meaning of parallel? Because of A state can goes to parallel in multiple state. Here, look at here this diagram. A only go to C or B, but with the one input. Okay, but A at the same time with one input it goes to B state. It can go to E state. It could be either A or B. So it chosen by the randomly. Okay. So this is a non-deterministic finite automata. Okay, let's see the formal definition of NFA. NFA, formal definition. Okay, let's see with the example. So what is a NFA? Here a simple diagram. This is the A state, this is the B state, B is the final state. Okay, so this is an example. Okay, let's see the formal definition. What is a NFA? NFA is actually a machine which accepts the set of strings, all strings that ends with a 0. So how do we know that? Look at the example. So this one is example. On getting a 0, it's come to be final state, because with 0 input it come to the final state. And how we show final state? This is the final state here. So this is a formal definition of NFA. Let's write it down like this one. Sigma delta. Okay, NFA. Okay, so what was an M? M is the set of all symbols. Okay, so what is a Q? Q is a finite set of state. What is a delta? Delta is a transition function from Q. And what is a sigma? Sigma is a set of inputs. So write it down here. A is a finite set of states. What is a sigma? Set of inputs. A finite set of input. What is delta? A transition function from Q into sigma. A transition function on from Q into sigma. Okay, so how this example we write it in simple way? This is an example. Okay, let's draw the state table. 0 and 1. What are your states? B is a final state. So A goes to 0, A, and B also, because this is a NFA. So it parallelly or multiple state. A goes to 0 with self state, and also it come to with 0 to B state. Now with one input it come to the self state. B the final state. So we directly write it down here. B is your final state. So this is a transition table. Of NFA. Okay, so we end here our today's lecture.